Ah, till which topic we studied and a recap.
Teacher, we had done structure of atom and had finished off the electrons, protons, and neutrons points last class.
Mhm. Yeah. So can you tell me about the uh, uh, how this rays were developed? They were found out, which was used, how the protons, electrons, and neutrons were discovered. Then we will start with models. Every 5 minutes in every class, first 5 minutes, I want the recap of the last class. Okay.
Okay. So,
Tell me
so
fast.
basically,
Whatever. Uh,
yeah. So discovery of protons was done by Goldstein. Uh, they were discovered in 1886 by the anode ray experiment.
hmm.
Then neutrons were discovered by Chadwick in 1932, and
Yes.
electrons were discovered by J.J. Thomson in J.J. Thomson.
Mhm.
No, sir, I don't think the year was given. I can't remember.
Fine, fine, fine. आगे बढ़ो जल्दी जल्दी. Fast.
Oh, right. Basically, the electrons were negatively charged particles, protons were positively charged, and neutrons were neutrally charged. A Crookes tube diagram was used for the discovery of the electron.
What was the name of the tube which was used?
Crookes tube or a cathode ray tube.
Very good. Yes.
Then the cathode rays have both mass and charge. I remember this because this was one of the questions you had asked.
Yes.
Then you explained the E by M ratio. Protons were discovered by the anode ray experiment. There were various properties of protons, such as the fact that no, of anode rays, such as the fact that uh, the E by M ratio of anode rays is less than electrons. Anode rays produce
Mhm.
flashes of light on ZNS. Then they get swinged by external magnetic fields.
Mhm.
They travel in straight lines and they are positively charged.
Yes. Good. Then
Then,
you've covered everything.
not sure, not sure.
Then make yourself bit fast.
Yes, yes. Um, Neutrons were discovered by Chadwick in 1932. He discovered them by bombarding beryllium with a stream of alpha particles. Then the penetrating radiations were produced by these particles in the beryllium,
Mhm.
and these radiations consisted of neutral particles. Those
Mhm.
neutral particles were later called neutrons. It's a
Mhm.
fundamental. One important point is that it was a fundamental particle of all atomic nuclei except for hydrogen, because hydrogen
Yes.
does not have a nucleus.
Mhm. Okay, fine. Now let's start with today's topic, that is the models of atom. You know, based on this alpha particle scattering experiment, it was finally understood that the atoms are divisible. And atoms are divisible into three: the protons, electrons, and the neutrons. So first model, actually it was the Thomson who proposed the first model. But his model told that the the atom consists of a uniform sphere in which that sphere is totally made up of positive charged particles. Okay, like you cut a watermelon, the entire red part is positive and the black seeds, they are negative. They are electrons. Okay, and therefore this model is also known as plum pudding model. Okay, so
Okay.
why plum? Plum or plum, you can say that is the reasons. Right down. So the question is, what is the name of Thomson's model? It is the plum pudding model.
Okay. Teacher, in the
Yes,
third point, E are present at some places. What does that mean? I didn't
electrons are
like.
electrons are present at some places.
Okay.
Means positive charge inside positive charge. Like I told you now, watermelon, entire it is red. And in that black seeds are embedded. That way.
Oh,
Written.
yeah, teacher, I wrote.
Now there is a limitation of Thomson's theory. Now, what is that limitation? The first limitation was the mass of the atom. The mass of atoms is considered to be evenly spread over that atom. And you know, this is one of the assertion and reason questions of NEET. See, you are being asked various assertion and reason questions also. So this is, oh, where it's, this is one of the questions for assertion and reason in the NEET. Okay.
Okay.
Now, second is, it is a static model. Static means it is a stationary model. Actually, it is not at all showing that how the electrons will move. That is, it does not reflect the movement of electrons. Got it?
Got it.
Now we'll see the most important one, that is the, I'm rubbing it off. Okay.
Okay.
Now we'll see second, Rutherford's alpha particle scattering experiment. You know, the alpha particles are nothing, they are the positive particles only. So what Rutherford did, actually he bombarded high speed alpha particles. High speed alpha particles on a thin gold foil, and it gave following observations. First is the angular distance, or you can say the angular deflections. You know, this is the place from where the alpha particles originated. Okay. Now, this was the gold foil. So alpha particles, they originated and they strike the gold foil. And you know, there was one screen which was placed around it. This screen was nothing but the fluorescent screen, or you can say the phosphorescent screen, right? Like the X-ray screen, which is made up of zinc sulfide. So the angular deflection, so it used to emit from here and it used to deflect. So he took microscope and he studied the angular deflection, this deflection, because some rays, they went straight ahead, some deflected through small angle, and some totally deflected back. So what was the reason? Okay, so the angular deflection of scattered alpha particles. They were studied.
Teacher, could you show the previous screen? I wasn't done writing. Yeah, it's done.
So, what were the observations which were made? So, observations were, write down observations. Most of the alpha particles, that is, you can say 99%, passes through it. Passes through it without any deviation or deflection. Number two, some of the alpha particles were deflected through small angles. Then very few alpha particles were deflected by large angles. Okay.
Okay, teacher.
And occasionally. And occasionally, the alpha particle got deflected by 180 degree. It means very less alpha particle. It went straight. Very less means occasionally. It went straight and came back on its path. Can you tell me why this is so?
Teacher, because it hit the right angle, it passed by the golden foil and it deflected off the phosphorescent screen. Right.
But what was the reason? Why was the deflection taking place? See, the deflection was taking place because let's study the conclusions. What the conclusion is saying, that most of the alpha particles went straight. Through metal foil. Undeflected. It means that is there must be large empty space. Right? There must be large empty space within atom. Okay. Second, now since few of the alpha particles they were deflected from their original path. Through moderate angle. So it was concluded that whole of the positive charge is concentrated and the space occupied by this positive charge is very small, right?
Yes,
So
teacher.
what does it mean? Small space is present only in the center. So what happens? Should I rub?
No, teacher, I'm on the second point.
Okay, fine.
Yeah, teacher, done. In the second point, what's that last word? SP.
And small space. I'm rubbing it.
Oh,
And the small space occupied by this positive charge is very small in the atom. Okay. And finally, the next one is when alpha particles comes closer to this point, they bear a force of repulsion and diverge from their path. Okay, so we see that the positively charged, what it is saying this only, that positive is present inside and electrons are moving all around it. So when it will strike the positive, then alpha rays are positive. So positive will strike back, right? But when this alpha particle is moving apart from the nucleus, then either they will strike the negative charge or there will be nothing. So if there is nothing, then it will move straight. Okay. If they have a bit of electron, then slight repulsion because obstruction in their path. Are you getting? So
Yes, getting.
therefore, yeah. So whole positive charge is concentrated. So positively charged heavy mass which occupies only a small volume. Only a small volume in an atom is known as nucleus. So where is nucleus present? Nucleus is present at the center of the atom. Number 2, a very few of the alpha particles a very few of the alpha particles suffered strong diversions on even returned on their path. Means that they were deviated and many of them they came, like deviation was there and many of them they went straight and came back straight on their path. Now why this is so? You know what is recoiling?
Yes, teacher.
Yes. So then you written, Shraira?
No, no, I'm not written. Right.
Oh, write down, then I will explain. Yeah.
Yeah, teacher, done.
Yes. So, yeah. Now tell me why this is so. It returned on their path. What it is indicating?
Path is indicating that it suffered a huge diversion from its path, and due to the force, came back on its path as well.
Yeah, nucleus is rigid. Nucleus is rigid and the alpha particles. Alpha particles means what? The helium, right? The positive
Yes,
particles. They recoil. Now, why do they recoil? Recoiling took place. Why it recoiled?
because of the pull of the nucleus in the
Very
atom.
good. So you will write that due to direct collision with heavy positively charged mass. Okay.
Okay,
Now what is next? C. Written.
on the last.
C. We see that as atomic number increases, the number of protons, what? The number of protons increases. So when number of proton increases, so what will happen? This increases which increases the repulsion. Okay. So the repulsion in them increases. And since the repulsion increases, so deflection angle theta increases. Okay. So what is the reason we are getting this? So basically, what do we see? We see that atom has two parts. Okay. Done?
Yeah, teacher.
Atom has two parts. Now, can you tell me what are these two parts?
Atom has two parts. All the electrons and protons.
Nuclear part and
Nuclear
the
part and
second is
extra nuclear.
extra nuclear part. Yes, two parts. So, in the nuclear part, you have mass. And in the extra nuclear part, you have two things, size and volume. Now, what is the size of nucleus? Size of nucleus is 10 raised to minus 13 centimeter. Or you can say 10 raised to minus 15 minute. That is equal to 1 Fermi. So you can meter. So you can say 1 Fermi is equal to 10 raised to minus 15 meter. And what is the size of an atom? Now we will compare. Size of an atom is equal to 10 raised to minus 8 centimeter. Or you can say 10 raised to minus 10 meter. Or you can say 1 angstroms. Okay. 1 angstroms or 10 raised to minus 10 meter. Got it?
Yes, teacher. 1 second, just.
Uh-huh. Done?
On the last one.
Okay, fine.
Yeah, teacher, done.
So what we will say, we will write down that R radius of nucleus, radius of atom. This will be what? Diameter of nucleus divided by diameter of atom. Diameter of nucleus is 10 raised to minus 13. Diameter of atom is 10 raised to minus 8. This is in centimeters. So the ratio is 10 raised to minus 5. Right? So what we are seeing that there's a difference of 10 raised to minus 5. So what does it mean? It means that the nucleus is so small. 10 raised to minus 13 is very small. Okay. So this is the ratio of nucleus to the ratio of atom. It means that if atom is this huge big 5 times, this is the nucleus. Okay. And density of nucleus is how much? Plus 10 raised to 17 kg per meter cube. Done?
Here.
Now, what is the limitation of Rutherford alpha particle scattering experiment? Do you have any idea? This is your assertion reason need question. What is the limitation? The first limitation is C. It says that this is the positive charge nucleus and electrons, they keep on rotating all around it. But you know what happens is, if electrons, they keep on rotating, then what will happen? It will continue to rotate, and finally it will fall. Right? Why? Because it radiates energy. Whenever any shooting star falls on the Earth's surface, what happens? It is radiating energy, right?
Yes.
So it radiates energy. And when it is radiating energy, then it will fall. And apart from that, there are other electrons also. So when electrons move, they will collide. They will fall. If they will fall inside the nucleus, then no atom. No stability, no atom. But this is not happening, right?
Yes.
Therefore, he proved this model was wrong. Means this model actually, concept was okay, but you know, it could not explain why. So the first limitation was it does not obey Maxwell theory of electrodynamics. Charged particle in attractive field revolves. Now, why does it revolve? It revolves to emit its energy. So, its loop is reduced and collide with nucleus. Okay, right.
Yeah, teacher, I'm here. My laptop just shut down.
Pardon?
My laptop had just shut down, so I'm here on the phone now. Sorry for leaving.
No, right on.
Okay.
Written?
Almost, teacher, almost.
Okay, fine. Be comfortable.
Teacher, in the second last line, the second word, what is that?
Its loop is reduced. Loop
Okay.
means this.
Okay, teacher.
So first of all, it will go fast, then it will come close, 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 and finally.
Okay, ma'am. Yeah, teacher, I finished. Teacher, I'm done with the notes.
Yes, done.
Yeah, teacher, done.
Okay. So basically, what we see that if this is a positive charge, electrons is moving around it, then continuous, draw this, continuous energy emits, right? Then you will get spectrum also, right? And this spectrum should be a continuous one. Why? Because if energy is emitted continuously, then continuous spectrum should be observed. But in reality, it does not occur. But in reality, this continuous spectrum occurred. So therefore, this law was not, this model was 100% not accepted. For accepting, you have to prove. See, science needs proving. If you can prove, tell me. If you cannot prove, get lost. Okay. So this was it. Hope this is
Okay.
totally clear. You can go through this and then we will go ahead with atomic number and masses. Yeah. Because this is
Okay.
very important. It is important from your, if you will give you will give grade 11 exam also, no? So this is important for
Yes,
that
yes.
also. This is important for assertion, reason, important NEET question. And you know, beta, NEET question does not involve only MCQs. It has got assertions and reasons also. So assertion
Yeah,
and reason who can give? The one who knows very well the theory, right?
yes, yes. Yeah, teacher, I'm done, right? Done writing.
Now you tell me fast.
Yeah, teacher. What do I tell?
This topic, what we have studied.
Okay. So, so till now, whatever we have studied, right?
Till now means today's class.
Yeah, yeah.
It is very
Today's class.
important.
Okay. So first of all, we started with the models of atoms explanation and the people who have founded those models. First, the first person who made a model of an atom is J.J. Thomson. He proposed the plum pudding model, and the statement that you gave was that he is that the atom consists of a uniform sphere of positive charge in which electrons are present in some places. One limitation of that was that the mass of the atoms is considered to be evenly spread over the atom mass. That question could come as an assertion and reason also, you told. Then after that, Rutherford's alpha scattering experiment. Uh, he had bombarded high-speed alpha particles on a thin golden foil, and uh, these alpha particles were positive. First of all, the angular deflection in this experiment, the observations was that most of the particles, that is 99%, they pass through it. They pass through the golden foil without any deviation. Second, some of the alpha particles got deflected by very small angles and hit the phosphorescent or fluorescent screen. Then very few particles got deflected by large angles, and some of them managed to get deflected by 180 degrees and come back to the source of the alpha particles. Then after that you give the conclusion, which is that uh, there must be a large empty space within, because most of the alpha particles went straight through the golden foil. Then then the second one is that since few of the alpha particles were deflected from their original path through moderate angle, whole of the concentrated in small spaces which were occupied by the charge, and this is very small in the atom. Then uske baad, third point, when alpha particles come to this point, they bear a force of repulsion and divert from their path, and the positively charged heavy mass, which occupies only a value, small volume in an atom, is known as the nucleus. Then,
Yes. Yes. So,
then,
yeah, fine. So, good.
but kuch nahi. I just wanted to say the next point, but yeah, go ahead.
Okay, fine. Chalo, now next we will see. I hope you know about the atomic number and mass number, right? Or should I tell you?
Atomic number, yes. Atomic mass, yeah, I'm clear on that too.
Okay, you know that now. Now I will tell you directly. Write down this topic so that we are in continuation with it. So atomic
Oh,
number and atomic mass, you know very well. Now there was one neat question. If you know, I'm putting that question. The number of electrons. Neat question. The number of electrons and neutrons of an element is 18 and 20 respectively. Find the mass number. Yes, fast.
Yeah, teacher, done.
Bolo.
Yeah, teacher, I finished writing.
Tell me the answer. Mass number. I'm waiting for an answer.
Acha.
Electron is
Sir.
18. Neutron is 20. So what is the mass number?
Okay, teacher, just 1 second, I'm calculating.
Yeah.
It will be 38 because it will be electron plus neutron, right?
Good. Chalo. Now next is atomic weights. Now this is again most important question which is being asked. Now supposing, what is it? It is the average of average of weights. Means it is basically talking about the isotopes. Okay. So what we have to take, we will add up the isotopes first of all. So therefore it is written that it is the average of weights of all the isotopes of that element. Okay, so we can say that if an element is has two isotopes, you can say Z1 and Z2. And they are and the weights are W1 and W2. Okay, the weights are W1 and W2 and their percentage occurrence. Means in what percentage are they found? Then in percentage of their occurrence is X1 and X2 respectively. It means we have taken two isotopes. Supposing we have taken isotope of chlorine, right? There are two isotopes of chlorine, chlorine 17, 35 and 37. And this 35, it is 90% occurring. And this 37 is only 10%, which is occurring in the nature. Then how are you going to find out the average atomic weight of element? Okay, written this.
Yeah, teacher, I'm almost done.
Are you understanding this?
Yeah, teacher, I'm able to understand.
Okay,
I'm understanding it while writing it. That's why it's taking some time.
No. See, we can take 2-3 extra classes. We can be 2-3 classes delayed. But the thing is that we have to understand everything in every class so that
Yes, teacher.
our time is not wasted in studying it again. You understood, you have to just revise. Are you getting? Because
Yes.
the syllabus is
Yes.
huge. The syllabus is huge. Yeah. So
Yeah,
what
teacher, I'm
is
done.
not written?
No, I finished.
Okay. So what will be average weight? Average weight will be is equal to W1 into X1 plus W2 into X2 divided by X1 plus X2. So this way, if they ask you to find out the average atomic weight of element, this way you will find. Written?
Yeah, teacher, almost. Just 1 second. Yeah, teacher, done.
So what we will see that atomic weight is what? Atomic weight, it is the average of weights of all the isotopes which are present in that element. Okay, so that average weight we have, I've already given you this. So you have to do the weight. Then what we will do, you will multiply by the percentage occurrence. Then the weight of second isotope multiply by the occurrence, and then you have to add up the 2% occurrence. Got it? This way we will calculate. There are many questions based on this that we will try to do in next class. And then we will be starting with isotopes, isobars, isodiphers, isosters, and isoelectronic species. In this isoelectronic species is a neat question, and this is also very, very important. You can say the formula. You have to remember it. Okay?
Okay.
Sure. Bye.
Bye, teacher.
Bye. Okay, ma'am. I'm leaving. Bye.